Hello, welcome to today's class. My name is Teacher Elvis, and I'll be taking you through chemistry form 2. We will be handling carbon and its compounds, and specifically the area that has given students many challenges. A lot of challenges. Students usually ask questions on Solvay process, and that's what we're going to do. Apart from this video, there are also going to be a couple of videos also handling other areas of carbon and its compounds, so be sure to check it out. But for today, we're going to be handling Solvay process. So by the end of this topic, you should be able to know the following. So we're going to highlight the objectives of this lesson. Number one is that by the end of this topic, you should be able to define Solvay process. Number two, the student must be able to state or enumerate, the raw materials that are needed for Solvay process. Number three, you should also be able to write chemical equations of the reactions taking place, in different chambers. Number four, the student should also be able to state the main product of Solvay process. And lastly, you should also be able to, number five, also be able to state the main raw materials, the main byproduct of Solvay process. So we can start. Be sure to have somewhere you're writing. So defining Solvay process. So Solvay process is an industrial process that leads to the manufacture of sodium carbonate as the final product. So what we are manufacturing in Solvay process is sodium carbonate. That's the end product. And in that definition, you realize that I use the word the main, because there are other products of Solvay process, but those are not the main ones. Okay? So sodium carbonate is the main product of Solvay process. Now, one, I say that it's an industrial process. It means that it takes place in the industries. So there are some companies in this nation that are responsible. Their work is only to produce this. So for a company to produce a certain product, that product must be of a commercial value. Okay? So what are some of the uses of sodium carbonate? What are some of the uses of sodium carbonate? Before you engage in the production of anything, you must know how useful is that product. So number one is that sodium carbonate is used in making glass. So used in making glass. So the glass that you see, the window panes, all the glass that you see has components of what? Of sodium carbonate. Number two, sodium carbonate is also used in making soap. Yeah, the bar soap that you see around, Menengai, Kibuyu, and many others. they have sodium carbonate as a component. Number 3 is that it's also used in paper making, paper making industries. Yeah. So the books that we use for writing, sodium carbonate is a component of the process involved in making books from trees. And then also sodium carbonate is also used in softening hard water. Hard water is a water that has got magnesium ions, calcium ions, sulfate ions. For some of you who are in Form 4, you handle this in organic chemistry too. So there is a way that sodium carbonate, when added to hard water that contains magnesium ions, there will be an exchange of ions, and those ions are usually removed when they combine with what? When they combine with the sodium from sodium carbonate. So it is used in softening hard water to remove those ions that make water hard. And so these are the main uses of sodium carbonate that you need to know. Now, after mentioning the uses of sodium carbonate, this one means that the companies that are involved in making glass will buy sodium carbonate from the companies that manufacture it. Just like those that make soap, those that make paper, and those that are responsible for softening hard water. Now, once you have known that whatever you want to make is of a commercial value, the next thing that you will look for is what do I need? What do I need in order to manufacture what I am interested in? So those are the raw materials. What are the raw materials for Solvay process? Another important area to consider. Number 1 is you will need what is known as brine. Brine is what is known as concentrated sodium chloride solution. So that's how you prepare brine. You take sodium chloride, which is a salt, and you put it in water in such a way that it's so concentrated. That solution is what scientists gave us a name, and they call it brine. So there is an aspect of sodium chloride here, there is also an aspect of water here. Number 2, you also need limestone. Limestone is also known as calcium carbonate. So the other name of limestone is calcium carbonate. The next thing we shall look at how these things are used when we look at the process of the Solvay process. We look at the manufacture of sodium carbonate. Then we also need so brine, limestone. You also need ammonia gas. Ammonia gas. And lastly, you need coke. Now, it is very, very important for students to know that the main raw materials for Solvay process is brine, limestone, and ammonia. But if in an exam you are asked for 4 of them, then you can include coke as one of them. But coke should not be the first one that you're going to mention as a raw material for Solvay process, though it's also very, very important. So after looking at raw materials, so we know the uses of sodium carbonate. We have the raw materials ready, and also the machinery to make that industrial product is also ready. We can now go to the aspect of manufacture of sodium carbonate, what we call Solvay process. Now, so the first thing that happens is that brine, which I say is concentrated sodium chloride. So there's an aspect of water, there is also an aspect of sodium chloride. Brine is brought into a chamber, and in this chamber, brine is going to meet a gas, and this is ammonia gas. Okay? So brine comes in and then mixes with ammonia gas. What is formed out of that mixture is what they call ammonia called brine. Ammonia called brine, or there are other books that call it ammoniated brine. Ammoniated brine. The two things mean the same thing. Now, this chamber where brine mixes with ammonia is what is known as the absorption tower. Absorption tower. So in the absorption tower, brine mixes with ammonia to form ammoniated brine or ammonia-called brine. The mixture of the two, remember, this is not a compound. It is just a mixture where sodium chloride, water, and ammonia have just mixed. There's no reaction taking place there. Now, the two are brought into another chamber. Sorry, the mixture is brought into another chamber, and in this chamber, the ammoniated brine reacts with carbon 4 oxide. This is what is known as the carbonator. Just from the word carbon 4 oxide, so the carbonator. Okay. Now, in the carbonator, ammoniated brine reacts with the carbon 4 oxide to form two salts. And I'll show you from a chemical equation how those two salts are formed. So we have ammonium chloride and sodium hydrogen carbonate. How sodium hydrogen carbonate? Brine containing sodium chloride and water and CO2. When these three mixes, what you'll have is sodium hydrogen carbonate. So sodium from the sodium chloride mixes with, so sodium from the sodium chloride and water and CO2 will give you sodium hydrogen carbonate. And then ammonia from the ammoniated brine will combine with the chloride ions there to form ammonium chloride. Now, these two salts are highly soluble in water, but we need to separate them because what we want is sodium carbonate. So we have to bring them to a chamber where the two will be separated, and this chamber is the filter. Now, for you to be able to effectively separate the two by filtration, one of them must precipitate as a solid. Because you can't separate two soluble solids that have dissolved in water unless one of them precipitates as a solid. So for us to be able to precipitate one of them as a solid, we have to maintain a special condition within the filter, and that is very low temperatures must be maintained within the filter. When that one happens, then sodium hydrogen carbonate will precipitate as a solid at very low temperatures. Ammonium chloride will remain in solution form. Okay, so very low temperatures here, and then so what comes here is sodium hydrogen carbonate will be filtered out, and then what will come out here is ammonium chloride will come out. So the sodium hydrogen carbonate that has come out there will bring it to another chamber here known as the roaster. In the roaster, we are going to expose the sodium hydrogen carbonate under intense heating from the word roasting. Okay? And the reason why we are heating it is because we want to remove the water molecules that are in sodium hydrogen carbonate. Okay? So here, sodium hydrogen carbonate will undergo intense heating, and so the water molecule that I told you was present here will be removed. So you have sodium carbonate, the water molecule that is there, and then a small amount of CO2 will also be given out. So to balance this equation, you put 2 here, so you have solid, this solid is also solid, and then this is liquid water, and then that is the gas. So that equation is balanced. This is the equation of the reaction that is taking place in the roaster. So what do you realize? You see sodium carbonate. Sodium carbonate has been released. Sodium carbonate, let me put it the other side. Let me put it here. So here, sodium carbonate has come out as what? As a product. Remember, when we are starting, I had mentioned that Solvay process leads to the formation of sodium carbonate as the final product. Now, but we don't stop the reaction here. We don't stop the process here because there are other substances that have been formed in this process that are very useful, and we will have to recycle them for our so that our industrial process is economical. Okay, so remember we talked about ammonium chloride coming out from the filter. So this ammonium chloride, allow me to extend this. So this ammonium chloride will come somewhere. I'm going to show you where. Now, where did the carbon 4 oxide come from? Carbon 4 oxide comes from a chamber known as the limestone kiln. A kiln is where limestone is intensely heated, so that it decomposes. So calcium carbonate, when exposed to intense heating, it will decompose to form calcium oxide plus CO2. Okay, this CO2 you're seeing here is what goes to the carbonator. Now, the calcium oxide that has been formed here is not wasted. That calcium oxide comes here. So what am I bringing here? I'm bringing calcium oxide. And this calcium oxide, I bring it to a chamber. And that chamber is what is known as the slaker. You know, in chemistry, when we talk about slaking, slaking means addition of water. So what am I going to bring in here? I bring in water. So water is coming into the slaker, and calcium oxide is going to be reacting with water. When that one happens, what will come out of the slaker is calcium hydroxide. Okay, which is aqueous. So what am I saying? Within the slaker, let me check. Yes, so calcium oxide is reacting with water in the slaker to form what? Calcium hydroxide. Okay, so this solid, that is liquid, and then this is aqueous. Okay, so that is why calcium hydroxide is also known as slaked lime. Okay, so calcium carbonate is limestone. Calcium oxide is what is known as the quicklime. For those of you who are taking agriculture, realize that when the soil is acidic and the farmer wants to reduce the acidity of the soil so that soil is able to support the growth of a particular plant, they will use quicklime, is calcium oxide. So when you take quicklime and then you add water into it, then now what you have is slaked lime. So slaked lime is calcium hydroxide. Now this calcium hydroxide that has been formed here is now what comes into a chamber here, large chamber here. Okay, and this large chamber here, the ammonium chloride that was removed from the filter comes, and there you are, and then it reacts with calcium hydroxide. So this chamber here is what is known as ammonia regenerator. Why regenerator? Because it is not the main source of ammonia. It just regenerates ammonia. So if it was the main source, the chamber would have been called ammonia generator. But it is a regenerator. Allow me to extend this a bit. There. Correct. So ammonia regenerator. So we have now calcium hydroxide. Allow me to use the blue one. So calcium hydroxide slaked lime is reacting with ammonium chloride to give you calcium chloride, written as CaCl2, plus ammonia gas NH3 and then plus water. So slackline plus ammonium chloride giving you the three products. Now, this ammonia gas, this one. So you come to, you see, it comes here. So you see, there is an arrow from the ammonia regenerator, and ammonia is coming from the ammonia regenerator back to the absorption tower. Something also I got to mention is that the carbonator is also known as the Solvay tower. So you can call it the carbonator or the Solvay tower. Now, when this process was going on, you realize that even though we had produced our sodium carbonate, but the process still went on. And I mentioned that there are some products that were formed here that also needed to be recycled so that this process can be made economical. And one of them, you see, ammonia gas that has been produced is being recycled. So one of the recycled substances is ammonia gas. Another one is carbon 4 oxide coming from the limestone kiln. Is also a recycled substance. And lastly, it is water produced in the ammonia regenerator. It's also recycled. So these three, so when you ask for the recycled products, the recycled substances or substances that are recycled in this process, ammonia gas, carbon 4 oxide gas, and water. And remember, in chemistry, when you are asked to name, please don't give the chemical formula of the substance. Allow me to write here. So when you're asked to name, so the first question that you can be asked is name three substances that are recycled. Here is where you talk about ammonia. Please don't give the chemical symbol, give it in name. And then you have carbon 4 oxide and lastly water. Why do you have to recycle them? To make the process economical. Quickly, I want to look at the common questions that you'll always be asked in this process. Now remember that when a question involving Solvay process comes, it will not come in this format. Okay? When you look at this format, the way I've drawn it, you will not find it in any other book. It is a special design by me, how I understand it. You should also have a way you can draw this flow chart without necessarily following how it is drawn in the textbooks, because when the question comes, it will not be directly as it is drawn in your textbook. What you need to understand is that where is CO2 coming from? CO2 is coming from the limestone kiln. Where is ammonia coming from? Ammonia is coming from the ammonia regenerator. Okay? Where is sodium hydrogen carbonate taken to? Which chamber? Is usually the roaster. So any chamber where you see sodium carbonate coming out as a product, then you know that it's a roaster. Okay? Where are the two salts separated? It is usually the filter. So it doesn't matter how they draw it. Just need to understand where each and every product is coming from and where each and every substance that is needed for reaction is going in. Now, the first question you can be asked from a flowchart like this is, write the equation of the reaction taking place in a given chamber. So I have written the equation on limestone kiln. I have also written the equation in the roaster, also on the ammonia regenerator. But what about the carbonator? Okay, what takes place in the carbonator? So in the carbonator, Sodium chloride, the general equation, sodium chloride concentrated in water, what we call brine, mixes with ammonia from the ammonia regenerator or from the main source, which I will mention briefly, and then mixes with CO2 from the limestone kiln. This one gives you two salts: ammonium chloride and sodium hydrogen carbonate. Okay, so you can now balance the equation. I think the equation is balanced the way it is. So these are aqueous, and this is liquid, and this is a gas, this is a gas, and then this is aqueous, this is also aqueous. That is the overall reaction of the overall equation for the reaction taking place in the Solvay tap or in the carbonator. Okay. Another question you can be asked is to state the main source of ammonia for Solvay process. The main source for ammonia is the Haber process. The Haber process is the process in which ammonia is manufactured using nitrogen and hydrogen as the raw materials. You can see ammonia is NH3, so NH3 means there's nitrogen and then there's hydrogen. Haber process. For those of you who are in Form 3 and you've done nitrogen and its compounds, you're able to understand what Haber process is. For those of you who are still in Form 2, then just know that's a Haber process. Haber process is a process in which the process that involves large-scale manufacture of ammonia. Another question will be asked is that the Solvay plant is usually located near large water bodies. Okay, so you go to Lake Magadi, you go to other, you find that they're usually located near large water bodies. What is the reason behind that? It is because the reaction taking place in the carbonator is highly exothermic, and a lot of water is usually required to cool the carbonator. So the closer it is to a large water body, the easier the accessibility of water that is needed to cool the carbonator. So that question just say that. So if you're asked, why is it that the Solvay plant is usually located near large water bodies? Your response should be that because the reaction in the carbonator is highly exothermic and a lot of water is needed to cool the carbonator. Okay? And then maybe there could be other questions you can put in the comment section so that I'll be able to go through them. If you have any concern, you can also raise it there. Otherwise, this is the end of our class today. I hope you enjoyed the class. If this video was helpful to you, please ensure that you reach out to others by sharing. Please click on the like the video, and also you can also click the subscribe so that we're able to reach as many as possible. Thank you so much for your time. I hope you enjoyed the class. I was your teacher, Elvis. Thank you so much, and see you next time. Bye bye.